Hey guys, we're back for another quick video on rationalizing the denominator and working with radicals. So let's just go ahead and jump in and get started. Okay, as I said, we're going to talk about rationalizing the denominator. So the question is, well, what does rationalizing the denominator mean? Well, that simply involves when we're going to rewrite a radical, a radical expression as an equivalent expression in which the denominator, and I want to emphasize the word denominator, not the numerator, the denominator no longer contains any radicals. Okay, now what I mean by that is your numerator can have radicals, your denominator cannot. And so there's several different types of problems you're going to see. We're going to focus on this one with when it is just something like the square root of b in your denominator. Now I'm going to go ahead and work through a few examples and then I'll give you some steps on there. So I want to give you an example first, then we'll put steps. So first one, if you had something like 3 over the square root of 2. Okay, so that's kind of the problem we're talking about, in which it contains a radical in the denominator. And so what we're going to do is we're going to multiply both the numerator and the denominator by the square root of 2. Okay, now the question is, well, why did I choose the square root of 2? Well, let's just think about this real quick, because if I have the square root of 2 times the square root of 2, what I have is the square root of 4. Okay, because 2 times 2 is 4. Now, I want to make a comment in there. This is not always the true. That is only true if a and b, the numbers underneath the radical, are both positive. We'll talk about what happens when they're negative later on. But if they're both positive, then we can just multiply, and that gives us the square root of 4. And we know that the square root of 4 is 2. Okay, so the purpose of taking the square root of 2 times the square root of 2 is that we then no longer have any radicals. We have the whole number 2. Now, in fact, this is always true with all numbers. If you have the square root of x times the square root of x, it will always just equal x. And that is something that you need to be sure you jot down to remember. Now, as far as the numerator goes here, I have the whole number 3 times the square root of 2, and it's still just 3 square root of 2, 3 square root of 2. And that is actually as simple as I can go. Now, a lot of people will want to reduce those, the radical 2 and the 2. No, you can't do that, because a square root of 2 and a 2 are not the same thing. Okay, so let's just write down some steps then, and then we'll do another one. So the first step is to multiply numerator and denominator by the radical found in denominator. Okay, and then once we do that, we simply just simplify both. Okay, that's all you got to do. Okay, so let me do another one for you. So if you need to take a minute, pause, and copy this down, because I am going to erase the first example. Okay, so let me give you another example. How about if I have 2 divided by the square root of 5? So take a minute. How would you do 2 divided by the square root of 5? So hopefully you think, well, I need to multiply both the numerator and denominator by the square root of 5. On my numerator, I can't do anything but just leave it 2 square root of 5. But in the denominator, I know the square root of 5 times the square root of 5 is 5. And that is your final answer. Okay, again, if you need to jot that down, I'm going to erase that and we're going to do another one, so be sure you pause. Okay, so how about let's do something like 2 square root of 6. Something very easy. What would you do? And if you want to go ahead and pause it and try it on your own, that would be awesome. So I'm going to multiply both numerator and denominator by the square root of 6. Again, this gives me 2 square root of 6 over 6. Now, here's another example where I told you this simplifying might entail more than one thing. Because if you look at this, we know that 2/6 is just a regular fraction and it can be simplified. And so my answer here is actually the square root of 6 over 3. Okay, because this is like 1/3. I don't need the 1 there. If you put it there, that's okay, especially for right now, but it's unnecessary to have that there. Okay, so let's do a couple more. Okay, so I'm going to show you something different here. For this one, you'll notice that the radical is over everything. Okay, well, we can actually just rewrite this to the square root of 4 over the square root of 5. We can actually just write it as each individual one. Okay, and sometimes you want to do that. And so what I would do here, hopefully you as you're writing that, you say, well, hey, I know the square root of 4. Yes, you do. It's 2. And then I still have the square root of 5. Now I'm back to just what I showed you earlier. So we need to rationalize this. We're going to multiply both numerator and denominator by the square root of 5. So I get 2 square root of 5 over 5. Okay, see how that worked? Let's try number 2. Again, the first thing I'm going to do is square root of 3 over square root of 7. Now I'm going to rationalize. Now this one's a little different in the fact that both of the numerators contain radicals. Okay, so that's fine. This time we can multiply the two together. And the square root of 7 times the square root of 7 is 7. So a little bit different there on those problems. So again, I would pause and jot those down. Now I'm going to take just a minute just to back up and do another quick problem for you before we go on. If you'll look at this one, square root of 25 over the square root of 16, okay? Well, if they're both square roots like that, you can still think of them as two individual ones. And we know the square root of 25 is 5, and the square root of 16 is 4. And they're no longer any radicals, and we didn't even have to rationalize. So that made that one a little bit easier. Okay. So done with this video, we're going to talk more about rationalizing the denominator when there's more than just a single radical in the denominator. So again, make sure you note any questions that you have on these and be prepared to do more of these in class.